Okay, so we're going to try to determine which system has no solution. So different ways you could, you could solve each individual system. So let's say we wanted to solve for this one. All right, see if it has no solution. We could do substitution. We could take, since y is already by itself, we could take x plus 4 and plug that in for y in the other equation. If we do that, instead of y, we'll have x plus 4. And then you have a minus x, and that equals negative 4. Okay, so that's what we get here. X minus x, they cancel out, and you get 4 equals negative 4. And right away, I'm thinking that that's the one that has no solution, because you can't, 4 doesn't equal negative 4. If you got the same thing, if you had 4 equals 4, that would be infinite solutions. So, really, with that, another way you could do it is figure out if something has no solution. If you were to graph it on an x and y axis, 2 lines, and they're parallel, they would never cross. That means they have no solution. So when you look here, you could just solve this for y. Y equals positive x minus 4. The other equation is y equals positive x plus 4. They'd be parallel. They would never cross. Let's check some of the others, though. Let's see something that would have a solution. So let's talk about maybe C. If we plug this in for y right here in the other equation, we end up with 2x plus 5 equals 1/2 x plus 6. To solve that equation, we could multiply everything by 2. So 4x plus 10 equals x plus 12. And then subtract x on each side. We get 3x plus 10 equals 12. Minus 10, you get 2. And then divide by 3, and x equals 2/3. That is something. And you would plug 2/3 in for x up here to solve for y, and you'll get something else, and that would give you a solution. So that's A would be the one that has no solution.